seventh period. So like I said, when I was passing this out, we looked at multiplying on Friday, but just the distribution property. We were just distributing and then simplifying, combining like terms. Now we're looking at equations, so we're going to do that. We're going to have to distribute and simplify by combining like terms, but then we're also going to have to solve. So we're throwing in that extra step today of solving. So in number one, we're going to start pretty basic. Of course, my pen is going to fritz out when I'm trying to record because that's Murphy's Law, right? Try this real fast. Sometimes when I mess with the battery, it's back in. There we go. All right, so here in number one, again, if you need to separate your equation with that line down the equal sign so you can separate the left from the right side to keep your work organized and make sure you don't accidentally combine things that shouldn't be combined, go ahead and draw that line. Okay, so on the right side, I see a set of parentheses, and this is out front, which means, ooh, that was fancy. It needs to be distributed to everything inside the parentheses. Okay, in this case, it's just a negative. So all it's going to do is change the sign of all the terms in that parenthesis. So it's going to become negative a plus 9. Now the plus 1 is still there and it's still positive because it was not in the parentheses, right? Only what's in the parentheses gets distributed to. And on the left side, there's nothing to distribute or simplify. It's just a monomial on the left. So now that I've gotten rid of my parentheses on the right, I can see some like terms that can be combined. I see a positive 9 and a positive 1 that are both constant, so I can put those together. So this becomes negative a plus 10. So now the left and right are both as simplified as I can get them. So once I have all the simplifying done, I'm ready to start moving terms across that line, across that equals. So I want variables, that's my letter terms, to one side, and my constants, that's my terms without a letter, to the other side. So in this case, there's an A on both the left and right, but there's only a constant on the right. So I'm going to leave the constant on the right, and I'm going to move my variables to the left. So to move this negative a, I'm going to have to add it, because to move terms across that equal sign, we do the opposite operation, and what you do to one side, you do to the other. So it eliminates it from the right, leaving me with just the 10 over here on the right. On the left, what does that give me? I had negative 6a's and now I added 1, so yeah, that leaves me with negative 5a. In the solving we did with adding and subtracting polynomials last week, everything like simplified down nice and pretty to just a single variable. So we didn't have any coefficients to remove or to move, I should say. So who remembers from previous years, what do I do to get rid of this coefficient in front of the a? I'm going to divide. The reason I'm dividing is because to move things, I do opposite operation. And this is 5 times a, so the opposite is to divide. So divide the negative 5. What you do to one side, you do to the other. So that reduces down to just a equals negative 2. And I know I mentioned this last week, but I'll mention it again, because it's always worth mentioning. It will always work. You can always check your solutions by plugging them back into the original equation. Anytime you're solving, that means you're getting a solution, an answer. Plug it back in here. Everywhere we see a, if we were to plug in a negative 2 and evaluate the left and the right, they should come out equal. The left side should equal the right side. If you want to do that in Desmos, you can. Some of you can do it in your head relatively quickly, but you can always check your answers. I'm not going to as we do our notes, but if you're unsure if you've gotten the right answer when you're practicing, you can always plug into the original and it should make it a true statement. The left should equal the right. All right, 2 is slightly more complex because both the left and right-hand side of the equation have some distribution that needs to happen. So on the right side, it's just the negative. So again, it's just going to change the sign of those terms. And then on that right side, there's no combining like terms that needs to be done. There's a variable term and a constant term, and that's it. On the left side, when I look at the left, I can see I need to distribute this 3. So everything in that binomial in those parentheses is going to get multiplied by 3. So 3 times -7 is -21. And then we have our W. And then 3 times -3 would be -9. And then that 4W is still there added at the end. It didn't go away. We are not distributing to it because the parenthesis closed here. Okay, so on the left, are there like terms to combine this time? Yeah, they're the linear term, the W term. There's -21 and +4. What does that give us? Well, the -21 and the 4 is positive. Okay, so it should get less. Yeah, we should be going closer to 0. So it's -17W when I combine those. And then I've still got the -9. And then my right side is not changed. So now I've simplified both sides as much as I possibly can. I'm ready to start moving terms across that equal sign to get my variables to one side, my constants to the other. Okay, a lot of people always want to move variables to the left. That's great. You can do that every time if you wanted to, but you don't have to. Okay, you can move the variables to the right and the constants to the left. I tend to pick which direction I'm moving what based on the signs. See how I know I have to move by opposite? So if I want to move the W's, I would have to add 17 over, which is going to leave me with a positive over here. I like to be left with a positive term rather than a negative. Okay, it just makes life easier because later I don't have to divide by a negative. So I'm going to add the 17W to both sides because what we do to one side, we do to the other. And it eliminates from the left. Now, I can do this all in one line, or you can do this in a separate line, whatever your preference is. But because I moved the W's to the right, I know I need to move the constants to the left. So this 3 needs to be moved over here by subtraction to eliminate it from the right. So that is going to leave me -9 minus 3 is -12. And -W plus 16W, or excuse me, plus 17 is 16W. Okay, and what do we do to get rid of the coefficients in front of the variable? We're going to divide. So this time when I divide that, I don't get an integer. 12 does not divide by 16 to leave us with an integer, so we just reduce the fraction as much as possible. Y'all do get to use Desmos, so if you struggle with fractions, Desmos will reduce that for you, but it should reduce down to -3/4. Or if you prefer decimals, that would be -0.75. Yes, sir. Yeah, the pass is hanging up there. Just take it with you and hang it back up on your way back in. All right, let's try another one. Okay, number 3, I'm going to go a little faster. I'm going to pick up the speed a little bit, but y'all can still stop me and ask questions if you need to. Okay, I've got distribution on both sides again. It's just the negative sign on both sides. So here This is going to become positive 4x. This is going to become negative 8. And then the minus 3 stays as is. On the left side, it's just a negative as well. So it's going to change this to negative 5x plus 10. And the 10x is going to stay as is. So I'm going to combine like terms. I see some like terms on the left, 2x terms that can be combined. And on the right, I see constants that can be combined. So I'm going to combine like terms on each side. So here that's 5x plus 10. And here that's 4x minus 11. Now, in my case, I want to keep my variable positive if I can. So I'm going to move the 4x to the left by subtraction because that's the opposite operation. So it eliminates it from the right, which means I moved my variables to the left. So I'm going to move my constants to the right. So I'm going to subtract 10 over here to eliminate it there. So this comes down, I combine like terms and I get x equals negative 21.
Can I use the rest of the day?
Yeah. So far so good? All right, let's do it again with 4. This time we've got more complex distribution because we've got numbers. It's not just a negative sign being distributed. So this is going to be negative 9y minus 9 plus y stays as is. And on the left, now here it is a negative 3. Be very careful that you get the coefficient and its sign. So since it was minus 3 times all of this, we distribute the negative 3 because the negative and the 3 both have to be distributed. So when I distribute that, I get negative, come on. I don't know why all this is highlighted. Come on, get out of here. Okay, so it is negative 27y, and that will be minus 12. And then that 7y in front is still there, unchanged. So now again, I'm going to combine like terms. On the left side, I have variable terms that will combine. These are my linear terms, just y's. And on the right, same thing. I'm going to use a different color because I don't want you to think you're going to combine the left and right. You combine them separately. What's on the left gets combined, what's on the right gets combined. Just because those are all y's, we don't combine them across the equals. So this is negative 20y. Why is it deleting? Seriously? Oh my gosh. I don't care. Ignore. All right, so negative 20y minus 12. And when we combine over here, that's negative 8y minus 9. So now I'm ready to move terms across the equation. So I'm going to move the 20y to the right by adding it, because that's going to give me a positive y value. And I'm going to then move my constant, the negative 9 over here, I'm going to add it to the other side to eliminate it over there. So that gives me negative 3 equals 12y. And now I've got a coefficient I need to get rid of. So I'm going to divide it out. Again, I have a fraction. I can reduce my fraction to negative 1/4, or if you prefer a decimal, that's negative 0.25. How are we feeling about multiplying and solving? The lengthier process for sure than what we were doing last week, but it's the same steps, we're just putting them all together now. So it makes them a little bit longer on some of these. Okay, on the back is some word problems. I'm going to go through them with you. Your Delta Math practice does not have any word problems, but you need to be able to interpret the word problems into equations. And the main issue that tends to happen, like a common place to make a mistake, is plugging things into the wrong place. So we really want to focus on what gets plugged in where. The formula is given here. This number 5 is talking about area of a trapezoid. And if you read through this, it tells you what's going to get plugged in where, and it gives you the formula. So I'm going to color code. They tell us that the height is 2x plus 9. So height, that's the h. I'm going to replace that with 2x plus 9. They tell us that the bases can be represented as 3x minus 7 and 3x plus 5. Remember, there's two bases of a trapezoid, and they get added together in the equation here. I'm going to add those two binomials together in the middle. And then the area itself, they tell us, is 25. So that's going to get plugged in for A in the equation. Okay, so we would have 25 equals 1/2. Now, here in the parentheses, I'm adding these two binomials. When I'm adding binomials, or when I'm adding any polynomials, I don't have to have parentheses inside this. I do need to separate it for the formula with these parentheses, but inside, because it's addition, I'm just going to write the terms. 3x minus 7 plus negative 3x plus 5. And then the height is plugged in. I'm going to put that in parentheses because it's also a binomial, 2x plus 9. So I plug 25 here, 2x plus 9 here, and then I did the bases here. Are y'all good with where I plugged in? What I plugged in where? All right, that's a really common place to make a mistake, is just the substitution step. Okay, once you get that, I think most of you can solve this okay. It's like what we were doing on the front. Okay, in parentheses here, we've got some like terms we can combine. What happens with the 3x and the negative 3x? Yeah, that's 0. So I'm just going to mark it out. It's gone. So then the like terms that I have to combine are negative 7 and positive 5. What is that going to combine to? A negative 2, right? So I've got negative 2 from all that in blue. It all came down to negative 2. And I've got to multiply that by half and then multiply it by 2x plus 9. Okay, if you want to have that line down the equation, you can, or down the equal sign, you can. So what's half of negative 2? Negative 1. So really, I've just got a negative that needs to be distributed here. Or, what else could I do? Instead of distributing this negative, what could I do instead? If I wanted to move it to solve for x. When it's up against a parenthesis like that, that means multiply, right? What's the opposite? So I could just divide it over to the other side to move it. Okay, either way, at the end, we're going to end up with the same thing. I think the majority of y'all would think to do the distribution here, and that's fine. We'll do it that way. So that's going to be negative 2x minus 9. Now we're going to solve for x. There's only one x term, so I'm going to leave it on the right, and I'm going to move the constant by addition. And then I'm going to get rid of the coefficient by division. The opposite of times -2 is to divide by -2. Now, is that my answer? Is that what the question asked me to find? Go back and read that problem and see what did the question ask us to do. What did it say to find? Find the value of h. Find the height. Is x the height? No. What represented the height? This 2x plus 9, right? So now I know what x is. So I can find the height by plugging x, -17 and 4x. Now, I know this comes out negative, and if this was a real world scenario, that wouldn't make sense. We don't have negative heights, but for the sake of our algebraic steps, that is correct. That comes out to -25. This just wasn't written as well as it could have been. Okay, but that does come out to -25. So pay attention to what word problems are asking for, because that's another common place to make a mistake, is to stop too soon or solve for something that they're not asking for. You got to make sure you're answering the question that was asked. Okay? All right, last but not least, we've got a rectangular prism. It has 6 faces, and they give us the length, width, and height in terms of x. So it says length, width, and height of a rectangular prism can be represented by, and then it gives us in terms of x. So that needs to be in the same order. So that is length, width, and height. Okay, they give us the formula to find the surface area of this prism in terms of length, width, and height. So we need to put it in terms of x. So we are going to substitute for all of the h's. We're going to substitute 5x. For all of the w's, we're going to substitute the 7x. And for all the l's, we're going to substitute the 3x. So when I write this in terms of x, it's going to look like this. Because these are the substitutions I made. Now, I can simplify this. So when I go to simplify this, yes, well? Because, so the formula is given here, and the way that they worded it, they said length, width, and height are represented by 3x, 7x, 5x, so it's got to be in the same order. So the first one they gave us corresponds to length, the second one to width, and the third one to height. Is that what you're asking? Okay. All right, so once I've got those substituted in, now I'm going to simplify. We reviewed our exponent rule last week. We said when you multiply like base variables, so x times x, okay, what you're doing is adding the exponent on them, the degree. And when a variable does not have an exponent, it's an understood 1. So x times x is going to be x squared, right? Does everybody agree with that? So we're going to multiply the numbers, and then the x times x is going to be x squared. So what's 3 times 7? So we got 21x squared here. 3 times 5 is 15. So we've got 15x squared. And then 7 times 5 is 35. x squared. Now we still have like terms. This is all still in parentheses, and these are now all like terms. They're all x squared terms, so we can combine them all. So what does 21 plus 15 plus 35 give us? 71 x squareds. Now that 2 is still out there in front to be multiplied. So that's 142 x squared. Now that one I'm going to double check. Is that what the question asked for? Write an expression in simplest form. Okay. Yes, that very first one we wrote was an expression to represent it, but they wanted us to get it down to simplest form. And that's as simple as we can get it, was the 142 x squared. We can't take it any further than that. All right, awesome. We've got about 15 minutes to work. You have a Delta Math assignment to practice this. So I want to just show you what that looks like real fast. On all of your assignments, guys, your percentage is a completion percentage. Okay, so just keep working till it's up to 100% complete. So we have the assignment, excuse me, the assignment from last week. If this is not done, it was due last night by 11:59 p.m. If you want to go back and finish that first, you can, but it is already late. Or actually, I'm sorry, I'm mixing y'all up with my CPM class. CPM's was due last night because they got it on Thursday. Y'all's is due tonight by 11:59 p.m. So I probably would work that one first if you're not done with it, because it's due today. Okay, and then when you finish it, you can start today's. Today's is short. It's only 8 problems. It's just like the front side of our notes. There's no word problems in it. So if you need to finish last Friday's assignment first, you can, and then work on this new one. Okay, so the one from Friday is due tonight by 11:59. The new one is due tomorrow by 11:59. And be sure when you don't finish stuff in class, you're utilizing that cat tracks time to get your stuff done.